We've just talked about model training. Model training produces a trained model. And once you have that trained model, it's really tempting to take the model and immediately deploy it. But that's dangerous since you have no idea how good the model is. We need to find out how good our predictions are. So before you deploy the model and before you ask it to start making predictions, you should always evaluate the model. We can't just look at how accurate the model is on the original training data. The model could simply memorize all the answers, but then it wouldn't do very well on new data after we deployed it. So typically, we do this. We don't show the model all of the data that we have. Instead, we split that data into two parts. Maybe we show the model 80% of the data and have it learn from that. And then we try out the model on the remaining 20%. Remember that we know the correct answer for all of our data because it is labeled. And so we can evaluate how well the model will do when faced with data it hasn't seen because we just saw it do that. We saw it do that on the 20% of the data. In machine learning, the 80% of the data is called the training data, and the 20% of data that we never show the model is called the test data. When someone asks you how good your model is, tell them how it does on the test data. But what number do you quote? We create what is called a confusion matrix by getting the prediction for each example in the test dataset, and then we count the number that occurred for every combination of label and prediction. Once you have the four numbers, accuracy can be computed simply by finding the fraction of times that the model is correct. In other words, the sum of the numbers in the green boxes divided by the total number of examples we evaluated over. Usually, accuracy is enough, but in some cases, you will be creating a machine learning model for rare occurrences. For example, you may be building a model to identify credit card fraud. The vast majority of transactions are not fraudulent. So even if the model says nothing is ever fraudulent, it will only get a very small fraction wrong. The accuracy will be something like 99.999%. In such cases, we use other metrics computed from the confusion matrix. Metrics that emphasize the performance on the rare stuff. So when the model training is finished, you have a file that has a set of parameters representing your trained model. The model has learned from the data, and now the model is capable of doing what you trained it to do. All the information that it has learned is in that model file. The purpose of evaluating a model is to figure out whether or not to move this trained model to the deployment phase. And the purpose of deploying your model is to make it accessible to those who want to use it for prediction. All cloud providers have a service for deploying models. On Google Cloud, the prediction service is also Cloud ML Engine. So Cloud ML Engine handles both training and deployment. When you deploy a model, you will get an API that's up and running and listening for requests. Send it the input data, and it will give you the prediction. Recall that you did this with the AutoML service in the previous module. You trained the model using the images of clouds or leaves, and the model was automatically deployed. And now, the resulting REST API, you could send an image, and you could get back a classification of what's in the image. Sometimes, prediction doesn't happen one at a time. Think about demand forecasting. We wanted to forecast how many bicycles will be rented at each bike share station tomorrow. we can simply run this at 10 p.m. every night for all the stations at the same time. Then we can have our crews go out and make sure that every bicycle rental station has a right number of bicycles. And that's what we did in BigQuery, and so that's another way to do predictions. In the graph on the right, I've depicted what periodic prediction looks like. Notice how the number of requests per unit of time is fixed. In contrast, in the graph on the left, you can see the number of requests over time, and you can see it varies. This is called interactive prediction. So you can do predictions interactively once for every user request, or you can do predictions once a day for all the stations that you're interested in forecasting for.